All right. Good afternoon, everybody. It's a great honor to be here, a great joy as well. This is an amazing institution, and part of the reason we are here is because we believe that the Vivekananda Institute of Professional Studies will be playing a lead role toward a Viksit Bharat. And the goals means we want to see ourselves as a fully developed nation by 2047. And here you see Modi say that we cannot stop until this dream of a developed India is fulfilled. But the first person to say this, of course, was the original Narendra. Stop not till the goal is reached. And we are here in this institution which is inspired by Swamiji. Thank you, sir, for setting up such a wonderful institution over here. This is incredible. I have spent about 4 decades in some of the best institutions in India. Most of my life, I served the IIT Madras. I have been affiliated with the IIT Tirupati, IISER Tirupati. I also served the IIT Mandi on deputation. I have worked with some of the best institutions in India, working with scientists and innovators in TFR, Raman Research Institute, and Indian Institute of Science and other places. And the atmosphere over here which you have created is awesome, sir. This is absolutely awesome. So I will share just a few slides toward building platforms and strategies for Viksit Bharat, which is today's theme. And as Udayji pointed out, the AI/ML and QML, which is quantum machine learning, these are going to be important, tools toward it. And also quantum hardware and devices. Now, it is important that we don't do it just as a spectator, but we need to have people who will be driving these technologies. And it is not easy to set up a quantum laboratory. There are few quantum computers, you must be knowing from the media, who are the major industry giants, and there are some other quantum computers which are being built all over the world, including in India. But maybe 5-10 years from now, there will be many more quantum computers. And even the manner in which computing is done using classical computers will be done in a different way because of these quantum computers. So it's very important to get hands-on experience in this, get into engineering skills. The cyclotron project which Udayji mentioned does not have anything directly to do with a quantum computer, but it has everything to do with engineering skills which are required to build a quantum computer. And that is the reason such projects are important. And I can foresee that the students and faculty in this institute will be one of the first private institutions, one of the first private universities. This institution will be a university very soon to participate in such projects. And it is destined to provide leadership toward Viksit Bharat. It's a little more than 2 decades away. And the good thing is that this institute has made a beginning now. And in this beginning, it is way ahead of most other universities or private institutions in the country. So I think this is a great place to make a beginning toward Viksit Bharat. Everybody knows that these are the 4 pillars of the National Quantum Mission: the quantum computing, quantum communication, quantum sensing, metrology, quantum materials and devices. And we need to get hands-on experience in each of these technologies. Now the question will come as to how do you do that, because you can't access a quantum computer easily. You can perhaps access some of the simulators, but we are not talking about what you can do just today or tomorrow. We are talking about what you should do today and tomorrow so that you can do it 5 years from now. And that is what I think we have some sort of a roadmap for this, and we have to get going along this. So here we are in Delhi. Let me tell you a little bit about my experience, which I would like to share with students and faculty over here. We have a Center for Atomic, Molecular, Optical Sciences and Technologies at Tirupati. Tirupati is the only town in India which has got an IIT as well as an ISER. I believe all of you are familiar with both the system of institutions. ISER is for science what IITs are for engineering. And Tirupati has both. So we set up a Center for Atomic, Molecular, Optical Sciences and Technologies because this is the domain field from which the technologies emerge. Quantum mechanics grew hand in hand with atomic physics about 100 years ago. And these sciences are driving these technologies. I also am affiliated with the RV University. For some reason, this university has come out of the trust which is called as the Rashtreeya Vidyalaya Trust. But the university is not called as the Rashtreeya Vidyalaya University. I have no idea why it is so. But it is registered only as RV University and not as Rashtreeya Vidyalaya University. So we have set up a Center for Quantum Sciences and Technologies at the RV University. Now going ahead, let me tell you that this center has some very learned people on its advisory council from all over the world. Science knows no borders, and we have some of the smartest people in the world who are advising us in developing the research programs and the technologies over here. I'm sharing a slide about the formation of this center. This was 4 years ago on the eve of independence on 14th August 2000. We were right in the middle of COVID, so this was a video conference event, online event. Dr. Arvinda Mitra, who was Scientific Secretary, Office of the Principal Scientific Advisor to the Government of India, inaugurated it. There were distinguished people from TFR, Inter-University Accelerator Center, Raman Research Institute, and so on, who are amongst the founding members of this center. Here are some projects which are being undertaken, like development of photonic and atomic vapor-based entangled photon sources. Now, these are some of the technologies which are needed to drive the future. And as you notice, the participants over here are not only from IIT Tirupati, but also from other institutions. IIT Delhi is here, Harishchandra Research Institute, Dr. Aditi Sende, the Bhatnagar awardee, one of the leading scientists in the country. This has a budget of about 15 crores. So there is some decent sized money which is involved in these projects. Nothing big for NVIDIA. There are projects on novel cryogenic gas phase spectroscopy scheme to explore ultra-fast dynamics of complex biological and astrophysical molecules. So these research projects are destined to make a major impact on the frontiers of science and technology. Even doing these experiments and as you develop them. Here is another one, quantum technology and photons, with photons and electrons. This is led by our collaborators from IIT Patna. They are driving this program. This has a slightly modest budget, but I mention it for a very specific reason. So I mentioned these three centers, and these affiliate centers that we are talking about go elsewhere. We are soon going to have a project going on at Mysuru, which is one of our immediate matter of immediate interest. Our collaborators are at IIT Madras, at Harishchandra Research Institute at Prayagraj, IIT Patna, Physical Research Laboratory at Ahmedabad, IIT Jodhpur, Jaipur National University, and many other places. I'm not showing everything because the dots get larger than the map. So I'm showing only some of the illustrative places which are involved. Envision India 2047. And this is a transformation that all of us, and particularly the youngsters over here, will be driving in the very near future. 4-pronged effort is required. I'm sure you are all aware of a number of faculty development projects, faculty development programs, workshops, which are being carried out across India. And they run over like 10 hours, 20 hours of teaching, acquaint students and faculty in some domains. I think what we are looking for is a faculty development program developed by the Vivekananda Institute of Professional Studies, which will be very different and very comprehensive. And it will be very different from any of these because, as we were talking yesterday, many of these programs are only teaching students and faculty members also just a little bit of Python and a little bit of accessing Quizzkit and so on. And they don't grasp any real understanding of quantum entanglement. They have no idea about quantum physics. They have no idea about Bell's theorems. And learning this will not enable us to have youngsters who will push the frontiers of science and technology. So we are very proud that we have every technology available in India, but we are also very concerned that much of this technology has been produced elsewhere and we have adapted it. There is very little that we have developed in India, means of course people like, we have this Hanuman that we will be talking about. NVIDIA is also making a big, contributing in a big way to developing these technologies. And I'm sure that the future will be different, so that we will be developing these technologies. But we need people who will know about quantum computing, not just by learning how to run a code using Quizzkit. And what we are proposing is the development of a 2-semester to begin with. I will come to its expanded version a bit later. But a 2-semester faculty development program, because first you need to train the trainer. So you need the faculty development program, and these are going to be needed across India, not only across India, but also elsewhere in the world, because many people are going to need to learn this, and those who are learning only how to use the IBM Quiz Kit will be left behind. So we want to develop these programs in which faculty at Vivekananda Institute of Professional Studies will contribute lectures. We do have some faculty, Utpalji is here, but we probably need more, and we can have some guest lecturers also, but we will coordinate it over here. The fulcrum will be at VIPS. So that is the first idea that I want to propose. Second will be to develop an undergraduate program, a BTech in quantum engineering. And there are some programs of this kind, but not many. There are very few, as a matter of fact. The references that you see on the screen is a paper in Nature just last year, November 2023. And there is two other references here: Building a Quantum Engineering Undergraduate Program, an undergraduate course on quantum computing, which is from the University of California. That is a recent paper published earlier this year. So these are very recent developments. Some universities are making an attempt in a small way. I'm proposing that we have a full-fledged undergraduate degree, BTech, in quantum engineering here at the Vivekananda Institute of Professional Studies. The third thing is we need people who will actually be engaged, means experiential learning is what Udayji talked about. And you have to be able to do experiments with your own hands. And these are not easy experiments. You do not have access to labs. You can't do it. You can't learn the engineering skills by just running some QuizKit codes. And you really have to get into this in a big way. You need skills in software as well as hardware. So we need to build a very large pool of skilled professionals who have experience not just in coding but doing the engineering. Because once you understand the Bell's theorem and quantum entanglement and so on, there is a huge amount of engineering. You have to be able to do soldering, you have to do so many experiments to have these repeaters so that you can employ this technology for your use. And you have to be able to do these experiments. So the third step after developing the faculty development program and developing an undergraduate degree program is to build a quantum laboratory, which is going to take some time, some money, but not a whole lot. And it is something which can be done in a few years' time. And that is the promise that we really want to take advantage of. And we can do it right here. We need a quantum laboratory. We can make a beginning with a small amount, means something like 5 crores or so will be a good beginning in the first year. And then in subsequent phases, we can expand it. So we can, begin with single photon sources and so on, and, slowly expand the laboratory. This is where I mentioned earlier that IIT Patna's project, which I mentioned earlier. So there are experimentalists who I collaborate with, and they will be involved. Means I'm basically a theoretical atomic physicist, but I work very closely with experimentalists who can provide and who will provide leadership. They've got a very nice proposal toward this program. And I think this is my last slide, because what all this will integrate into is a center for translational research in artificial intelligence and quantum technologies, which is what will drive all of these programs. So this will drive the faculty development program, this will drive the undergraduate program, it will drive the quantum laboratory, and some of the students over here will be able to participate in this. And this is something which you can begin to do now, not tomorrow, but within a year or two. You can make a beginning, and in 5 years, you will be way ahead of the rest of the country. And by 2047, you would have played perhaps the biggest role toward Viksit Bharat. Thank you very much.